This is 11.5, the distance formula and the midpoint formula. Right here. Here is your distance formula, and they're talking about the distance from one point on a graph to another. Now, because you can't just count the boxes because it's going diagonally, we have to use that distance formula, and here we'd subtract our x coordinates and square it, subtract our y coordinates and square it, and then we'd add those values together and square root the whole thing. The reason that this works, so your distance here, notice you went from an x coordinate here to here. Here's your distance of x coordinates. That's like your leg of your hypotenuse. Here's the distance from one y coordinate to the other y coordinate. It's like your b. And your Pythagorean theorem was a squared plus b squared equals c squared, right? Where your distance is your c value. And how would you find that? Well, you would square root your a squared plus your b squared. That's basically what this ends up being, where a is the distance traveled left and right, and b is the distance traveled up and down. Once you have that distance, we square it, add it to the other distance that's squared, and then square root that value. As I said, this all works off of the Pythagorean theorem. So when you find c, you'd have to square root that whole thing, and a is the distance from horizontally and b is the distance vertically. So let me show you how this works. So my ordered pairs, I have 4, -3, and -7, 2, where 4 is an x value and -7 is an x value. Not a y, an x, sorry. Okay, well, my distance is going to equal the square root of, let's find the distance between my x coordinates. I went from 4 to -7. 4 to -7 is actually a distance of 11 units, and I'm going to square that. My y coordinate is -3 to 2. Y coordinate, struggling there. Now, for that one, if I'm going from -3 to 2, that's actually a distance of 5 or -5. It actually doesn't matter because no matter what, 5 squared is the same thing as -5 squared. So 121 and then 25. It doesn't matter which direction you're thinking about going. All you need to know is the distance. From 4 to 7 is a distance of 11. From -3 to 2 is a distance of 5. That's all that really matters. We square those values, 21 and 25, and let's add them together. 146. And we're going to simplify like we've been doing in chapter 11. Can 146 divide by 4? Can it divide by 9? Can it divide by 25? Since none of those work, that is our actual answer. If it was like the square root of 120, we would simplify that. But that's kind of how your distance works. So on your checkpoint number 1, your distance equals the square root of, from 5 to 2 is a distance of 3. And from 1 to -3 is actually a distance of 4. So that is 9 plus 16, which is 25, and the square root of 25 is 5. My distance would be 5 exact units on that one. Here's going to be something interesting that they're going to do to you. They're going to tell you the distance, and they're going to give you one full point and ask you to complete the other point. So when I plug in my formula, I know what d is, and I actually know my distance from my x's. I go from 5 to a 9, and that's actually a distance of 4, so I could square that. I actually know that value. But I don't know my y's. That's what I'm trying to figure out, is what is that y coordinate that gives me the distance to 6. I strongly always recommend putting the variable first, but this is all I can do. A minus 6 squared. Well, I know what 4 squared is. It's 16. A minus 6 squared. Your note-taking guide wants to solve this a different way. I strongly recommend solving it my way. I need to get to that variable. The only problem is it's under this huge radical. Let's get rid of the huge radical by squaring it. So now I'm out from underneath of that radical, and I have, that's supposed to be 6. I have more of a shot of getting to my variable. But if I square that side, I have to square this side. And that's 4 times the square root of 2 times 4 times the square root of 2. So it actually equals 32. From here, you have a couple of different options. The book wants you to figure out what a minus 6 squared is and solve that. Well, it's a squared minus 12a plus 36. And then they want you to get everything in standard form. So a squared minus 12a for quadratic equations. Sound familiar? Those added together are 52. And when I subtract 32, that's 20. And then we could factor from there. Or I like my way. My way is getting this squared by itself. I can get rid of that squared by square rooting it, but I can't do that while the 16 is here. So let's subtract the 16. Now I have that 16 equals what a minus 6 squared is. Now I can square root this. And I have a minus 6. The only problem is, if my ordered pair is here, 9, 6, it's got a distance of 4 times the square root of 2 to my other 0.5 something. It could also have your distance going this way and have it be 5 something. I don't know which direction that 4 times the square root of 2 is going. So when I square root 16, I need to consider the positive and the negative 4. So when I add 6 to both sides, I need to think of positive 4 plus 6 and negative 4 plus 6. So a equals either 10 or 2. If I had kept going with my factoring, that should equal 0, sorry. What multiplies to 20 but adds to negative 12? Well, a minus 10 and a minus 2. That means a minus 10 equals 0 or a minus 2 equals 0. I still get the same answers. And that makes sense and it works. I can have an ordered pair of 5, 10 or 5, 2. If it's 5, 10, the distance for my y's is 4. And 4 squared would be 16, which would add to the 32. If my y coordinate is 2, my distance from 2 to 6 is still 4. It's just going the other direction. So you can tell me your two answers as 10 and 2, or you could fill in your ordered pairs, but this is fine for me. So let's practice that again. So my distance is the square root of 41. My x coordinates, I do know the distance between. From negative 1 to 3 is 4 squared, but I don't know my y's. And I'm going to put my variable first just because it is messy to have negative variables. So the square root of 41 is 16 plus b minus 2 squared. Let's get rid of that square root by squaring this whole thing and square that thing. Minus 2 squared. And 41 square rooted and then squared is plain old 41. Let's subtract 16 from both sides. And now I can square root that and get rid of that square. So b minus 2, but I have to think of the positive and negative 5 because I don't know which direction it's going. It could go either direction. So when I add 2 to both sides, it could be 5 plus 2 or negative 5 plus 2. That means b either equals 7 or negative 3. And it's okay to have a negative answer here because 3, and then it could either be 7 or negative 3. So I know my distance for my x's is 4 squared. Now from 2 to 7 is a distance of 5. From 2 to negative 3 is a distance of 5. And this is 16 plus 25. That's 41 square rooted. That is either one of those work. So it's okay to have a negative ordered pair here. So that is the distance formula. Here's the midpoint formula. The midpoint formula. Midpoint formula is just that. It is a point. It is an ordered pair that is exactly in the middle. Well, guess what's another word for in the middle? Average. If you look at these, this is exactly how we find the average of something. We'd add it all up and divide by how many values we have. It's basically the average of x and then the average of y as your ordered pair. That's it. So if my ordered pairs are negative 3, 7 and negative 1, 11, my midpoint, also known as m, is negative 3 plus negative 1 divided by 2. And then my y coordinate is 7 plus 11. Well, then my midpoint is negative 2 9, which makes sense. Look at my x-coordinates. What's in the middle of -3 and -1? -2. For your y-coordinates, what's in the middle of 9 or of 7 and 11? 9. It literally is just finding the average. So what's in the middle of 1 and 5? 3. My midpoint would be 3. What's in the middle of -2 and -4? -3. Ta-da! If you don't have a value that's a perfectly even, that's okay. What's in the middle of 5 and 13? 9. And in the middle of 12 and 9, if you can't think of what's in the middle, go to your average. 12 plus 9 divided by 2 would be 10.5. It's okay to have 0.5s and halvesies in ordered pairs. That's perfectly fine. The other thing you're going to see on your tests, or I'm sorry, on your homework, they're going to give you one ordered pair, 5, 2, but they're not going to tell you the other ordered pair. The information they will give you is the midpoint. So if 0, 4 is in the middle, what is this ordered pair on the end? Well, the first one was 5, 2. Well, from 5 to the middle, it went down 5 for the x-coordinate, goes down 5 again. From 2 to 4 for the y-coordinate went up 2. Keep going. Up 2 again. Don't make these ones too hard. This is the last thing you're going to see. They're going to ask you if it is a right triangle. If it is a right triangle, then a squared plus b squared equals c squared. That means I need a distance of a distance of b, and a distance of c. So I'm going to find the distance of this point to this point and call it my a. So here's my length of a. From -2 or -1 to 2 is a distance of 3, and then a distance of 3. So this is 9 plus 9. So my distance of a is the square root of 18. I'm going to make this point to this point my distance of b. Not d, how about b? So those are my two legs. So from 2 to 5 is the distance of 3 squared. From 4 to 1 is the distance of 3 squared. So b is the same thing, square root of 16 or 18. My distance of c is going to be from the first point to the third point. So from -1 to 5 is a distance of 6. And from 1 to 1 is actually a distance of 0. So this is 36 plus 0, and the square root of 36 is 6. If you now know your a, b, and c, you can do a squared plus b squared and see if that equals c squared. 18 plus 18, does it equal 36? Then these are the ordered pairs that create a right triangle, because I found the distance from between two of them, the distance between the next two, and the distance between the first and the third, and then I used those distances, and a squared plus b squared equals c squared. Hope that was fun.